All right, hello everyone. Thank you for having me, ITIC, Macquarie University, and IBM. So glad to see all of you guys here participating into Hackathon, AI enthusiasts. And I would love to talk about AI landscape a little bit today. As Steve just mentioned, I'm head of data science and AI at ACS. Bless you. Um, so if you know about ACS, we are industry peak for IT and ICT professionals. Essentially, we make sure we provide and enable you guys to become more successful in your career life. And I recently joined ACS because they know that AI and data science is going to be the next important enabler. Everybody probably knows about it already. But if you have any questions about why it's important, you can think about it as another exponential technology enabler, like mobile technology. Long time ago, when the mobile technology got introduced, it just revolutionized many other technologies down the track. You can see the impact, direct impact and indirect impact was huge. Still, we are not leveraging AI as much as we need to, especially in Australia. Unfortunately, it's not happening as much as the other countries. But hopefully with you guys, all the talented people, in future, we'll be able to catch up and be one of the main leaders in AI. AI is especially important in Australia. As you can see, we're using AI in different ways and lots of opportunities. Mining, automation, or even farming. These are some of the major industries in Australia that are using AI, and they're getting back the actual outcomes. And like you can see that they are even automating the maintenance of the harbor bridge. So Data 61 Cyro is responsible for maintenance of the harbor bridge. And it's very interesting that they're using many different IoT devices to understand where and when they need to intervene. Apart from that, Australia is in a very important position. We have some ozone problem, as you know. Skin cancer is one of the major death reports in Australia. It's a very big number. And as you know, AI can detect many of diseases early on and can help make decision making for doctors or even for users directly. So using an app can enable people just take a picture of your skin. It will tell you if there is any problem. And you can quickly go to doctor or prevent it. Many other use cases in Australia. Startup landscape, you can see major startup development is happening in AI. And I can say even cybersecurity and big data, robotics, they're all interrelated. They're all using similar technologies. Machine learning is the main enabler for all these technologies. Geographical location, as expected, New South Wales and Melbourne having the major hubs in AI and data science. It will be better to see more diversity. ACS is going to provide more facilities across Australia to make sure it is more democratized, more decentralized. Nothing in Northern Territory, unfortunately. That's so bad. Talking about startups, still we do have some good startups. We are not catching up with the rest of the world, unfortunately, yet. But one of the examples in the startup sector, Harrison AI, is working on AI-enabled technologies in healthcare. So to give you a little bit of idea what's happening, so they started 2 years ago by just digesting lots of images about IVF technology and understanding how they can find the best, let's say, egg for donation or implant. And based on those technologies, they understood that they have a really good model on image classification and understanding the images. And now they're rolling out their models into other health areas. The last one they have run their models was about the X-rays. X-rays are something takes a lot of time for doctors and medical practitioners to actually classify and diagnose. And these images can be easily digested by machine learning algorithm, and with high accuracy, it can produce the early suggestions. They have raised $30 million pretty much around the end of last year, and they're one of the major AI startups in Australia. If you would like to know what is happening next in Australia, you should have a look at the patents. Because if you think about it, companies who invent something or find something that will have an impact will first make sure that they can patent their applications, and then later it will be productionized. So if you think about the use cases, you will see healthcare is the first one. That's going to be the major revolution in Australia. Many of companies are thinking about healthcare. And it's also kind of aligned with the word. In the larger scales, global scale, most of the startups are focusing on education or healthcare. So if you're thinking about having another startup, maybe that's a good space to think about. And also, you can see image analysis and speech coming next in the core capabilities. So let me tell you, right now, text classification and NLP is pretty much matured. You're using it in many, many different use cases. You can think about Alexa talking to you all the time and pretty much getting very good results out of Google and Alexa, right? So that means the conversation and text understanding is right now matured, and it can be developed and deployed in industrial use cases. But still, image classification has a long way to go. So again, that's another opportunity. Fortunately, we don't see many of these patents in agriculture, which is one of the areas identified for future growth in Australia. Most of the patents are coming from one country, from China, 26,000 of them. The problem with AI and data science is the patents are a little bit complex, because sometimes these companies are patenting their model. So it's not about the algorithm, right? So it's like, okay, image classification, deep learning algorithm, done. Okay, all right, it's there, it's open source. But they're actually ingesting the data and patenting their models, which is very complex to actually claim. But because they want to make sure that they have the right to use the models, and also they have they're taking care of that applications, they just apply for it. I don't know how they want to enforce it. That's going to be very complex. Australia is 17th. Not too bad. But unfortunately, the quality doesn't seem very good. he had a look at many of these applications, and I can say more than 50% of them are too much research-oriented and no real industry value. And interestingly, State Grid Corporation is leading the whole world. 1,000 patents. It's like 4 times Australia. I don't know what they're applying for. Going back to the value. So you can see the value of AI in just one of the applications, like the mobile application, that you can see if you just have less congestions because people are using more new high-tech technologies, they would save a lot of money. It is divided in different sections. And AI as an enabler and as an exponential technology, it has the similar effect, and a lot of people actually predict that it will have more effect than the normal technologies that we have ever seen in our lives. It's going to be like electricity or even maybe more, like fire. It's like Google's CEO predicted. This is another interesting report about Australia versus the rest of the world. So you will see 2 major anomalies in Australia. Most of them are aligned, which is fine. Australians also believe it will improve the productivity, risk management, data capability, all the good stuff there. But you can see 2 of them down there, especially reducing operational cost. Australians don't believe that AI is going to help with that. And that's very interesting, because one of the major use cases for any technologies is just saving the operational costs. So you've seen that, like here, saving is the major one. And we don't believe that. Why? We have investigated, and it seems many of these projects are putting a lot of money into doing some research or maybe some projects that not directly improving or impacting their business cases. Or even maybe the improvement and impact is not aligned, or it's not something that they will think as cost effective. So you can think about it. Big banks are putting millions of dollars or maybe billions of dollars in AI projects right now. But because they don't have, some of them, they don't have really good understanding how to manage the projects, it will cost them more than it saves. And then on the back of that, there will be a lot of failures, a lot of failed projects. I have seen myself a couple of million-dollar projects failed just because of not having a good governance or not good management. And that's very unfortunate, because that will backfire. What happens next? They're very resistant into having new AI projects or onboarding new data scientists, because then the senior executives will not see the value, right? And it's very difficult to change their mindset. The senior executives, they will go with the hype, they adopt it, but if they fail, they will not get back to it very soon. So then you're going to graduate very soon and go to the market, and you'll see the demand is decreasing. And that's not aligned with the rest of the world. They're killing for data scientists in the other countries. And that's a little bit unfortunate. But we hope that we can change it. At ACS, we are trying to also do a little bit of culture shift. We are going to talk with directors and executives directly to let them know that if they have done something wrong, that doesn't mean the value is not there. Improved data governance, that's another important, interesting thing. I haven't done many research about it, why they don't believe that it will have a good impact on data governance. That's also another important and interesting thing. So in order to be an AI company, these are the maturity level. That there are different steps that you need to make sure as a company, as a business, to go through to deliver the real AI value. And I can see some of the projects will fail because they want to do a waterfall approach. So the waterfall approach, it will be like, make sure this layer will be done perfectly and completely, and then you go to the next level. And by the time that you're here, you already spent a couple $1 million and you haven't got anything back for your business. What I think will be the best way to do it is the agile approach where you do a cut through. You run a project and you deliver the whole value, end-to-end value to the business. So I know that it is very difficult with AI projects to actually cut the corners, but this is the reality. You cannot put billions of dollars into perfectioning the project and not delivering back anything. So, how to do it? These are a couple of steps. Execute a pilot project that's related to the business, directly related to the business, not walking around the bushes. If it is a bank, make sure you're saving money on something like either predicting fraud or recommending better products to the users. Communicating is very important. That's one of the major problems in companies. They don't have really good communications with data science team. They don't understand the impact. They don't understand what they will be delivered. The expectations goes wrong. And if you join a company as a data scientist, make sure you're communicating with your business holders. AI strategy or AI as a tactic, that's a good conversation. I'm not going to dive into it. Having an in-house AI team is very important because business changes rapidly and you need to deliver the value quickly to the business. You cannot always outsource it. You can start by outsourcing it to get the momentum started, deliver the value, but then down the track, if you want to get major value, you need to have your team into the business integrated so you can understand the little bits and pieces, and providing broad AI training. So finally, if you want to be a successful AI company or you want to be successful as an individual, make sure these are the 4 pillars you will always follow. Any project needs some freedom because it's a research, it's exploratory, and you need some freedom to explore. Embrace the failure. You guys probably going to join as a graduate or some data scientists, but the executives need to know and understand that. So make sure you communicate, make sure that they are understanding that there will be failures, there will be a lot of failures, and we will learn from it and will become better and better. That's how machine learning works. Machines are learning. You should always learn as well from your failures, and it will be built on iterations. It's not in one go. You just build it, deliver 100% accuracy, and that's it. No, it's always going to be feedback loop, get the data back, and understand and deliver. And finally, build in ethics. So ACS is also doing policy making in ethics and data privacy frameworks. And we love to make sure that this is implemented in any AI applications in Australia. Ethics are very important because many of these companies are using the data that they're not supposed to use. They're inferring some results that they might be biased, and they're not delivering transparency. So just make sure that if you're following the principles, you always follow the ethical principles. It might not be legally binding, but it's always ethics is the most important thing. Thank you very much for your time.
Hi, everyone. I changed my role in about this time last year. I'll explain what happened. Have a read of that, if you know Douglas Adams. Gee, can you guys hear me without the mic at the back? I'll just leave this down. It's easier for me to walk around. Oh, you need it for that? I can do that. So if you don't know Douglas Adams, he's the guy who wrote Hitchhiker's Guide to the Galaxy. He did Dirk Gently. He did like a whole bunch of really cool stuff, including Monty Python skits and Doctor Who scripts and the likes. I'm guessing you read that. So personally, as my career, I've been really lucky to focus on that last one. Generally, if you ask me what I do, I get invited to work with things that are not natural. That's my job, that's my skill, that's what I do. So right now, yes, I am the Asia Pacific leader for the Red Hat Synergy. So we have an office called the Red Hat Synergy because we are not integrating the company. We are keeping IBM and Red Hat separate because of various reasons. And I spend my day-to-day activities in setting up that process, setting up people who work with together and making sure our clients are always taken care of. But before that, I was the CTO for IBM Watson, which is the AI platform for IBM. And I did that for the last 6 years. So I was the first AI client architect for IBM outside the US. So I have spent my time going across the world, talking to organizations, understanding their requirements, and some of the stuff that Steve mentioned, keeping focus on business problems, recognizing that you will probably fail, and that's okay within context. The technology is changing dramatically fast, so what you started your project with, the technology will go ahead by the time you finish the project. So making sure that that continuous improvement is part of the AI discussion. How many of you are doing tech, like you're studying tech, you're implementing tech right now? Yeah, so generally when you are doing your builds and project builds, you build stuff, you plan stuff, you roll it, you test it out and test it out and test it out and test it out again, and then roll it out. Why? Because on that day it's shiny new and it's perfect as you would like it to be. If you are doing an AI project and if you have done your work well, that shiny new day for your project is going to be the worst day of its life. Different way of thinking, because AI in its core sense is about improvement. There are machine learning techniques in it. So every day, every interaction, it becomes better, which means the day you launch it is the worst day of its life. It's a different thinking. You have a conversation with your stakeholders about that topic. Like you're going to take X amount of dollars and you launch something that's going to be the worst the day you're going to launch it. But look, generally, when I talk about AI, two really broad topics get asked to me. One, which is the science of it. How much do you really need to know about the depths of AI? Do I need to know about the different neural networks? Do I need to know the difference between supervised versus reinforced learning? Actually knowing the science of it. The second part that gets asked, and this gets more debated, is the job impact, skill impact of AI. And I've been doing this for a while now, as you can gather. So I get asked this in all sorts of ways. And I'm extremely candid because I'm a practitioner. So I'm extremely candid. So if the questions you ask be, ready for the answers I'll give you, because I will probably tell you, but you might need to think of it differently. So on this point of the science, though, so IBM's done a lot of work in trying to make AI accessible. So when you now need AI skills, there's one type of AI skills that is the research side, which is building out platforms. You're building out how the model works. Then once you know how that works, then there is the what am I going to use this model for? Why will I need to use this model in business? That's actually a different skill. So the people who recognize where AI, ML will impact a business, benefit the customers, is a different kinds of skill than the people who are building out the underlying models and the science of it. So you do need different kinds of skills. There's a third kind of skills, which is probably the biggest and the most popular AI skill, which is the what part of it, which is I don't need to know how Watson understands an image. I just need to know which API to call, what image to send. Just know that it needs 5 kinds of classes, and because I'll look for 5 different things, and I'm going to send maybe 20 images per class. I know the API to call. I know how to curate my images and send it. I don't need to know the science behind what's happening at the back as to how it's doing the deep learning to understand and recognize an image. Okay, so we've spent a lot of time, and a lot of the vendors have done that. It's a lot comforting for me to say that now, because when I started the journey and I was talk to people about AI and Watson, people would just roll their eyes, because I'm talking 2013. And I was working with Woodside in 2014, amazing company, by the way, Australian company. They were ahead of us and they pushed us. But when I would speak to a senior executive in a bank and I would talk about AI, they would just roll their eyes at that point of time. So I've been very lucky to go through that process. On the other side of it, the jobs part of it, will jobs go away? Because that's I'm very candid again. That is the first that question that comes. It's not as much as it'll go away, as much as it will change. Without a drop of doubt here, every job in every function in every industry will change because of AI. You're all using AI in some form or other already. You are on a daily basis. I think Netflix has like 70% viewership based on recommendations it does. So stuff you're watching right now is being recommended to you by AI. It's happening. When you're doing internet searches, it's happening. So all of us are using it. So yeah, jobs will change. It'll change dramatically in some cases and not so dramatically in some cases. I was speaking to UNSW actually last weekend. There was a conversation where there was a lawyer in the room. And the conversation went from, you know what, so if you are a C-level exec today and you're a CTO or you are a CIO and you studied technology at university 25 years ago, the stuff you learned there is violently different from what you do today. But if you're a doctor, if you're a lawyer, there's still a lot of the original course content that you are using today. So skills will change, jobs will change differently depending on the level of expertise, depending on the level of scope of that industry, depending on the amount of automation that can be brought into that job function, etc. But ultimately, people forget AI is just another piece of tech. It is dramatic in its what it does. Yes, it is equated as, I think Kai-Fu Lee, and maybe that was the book that was being mentioned there, Kai-Fu Lee said was, it is the next general technology, like electricity or new, completely foundational technologies of the world. But this tech, what's unique about this tech is it's about humans. Hear me out. So I've been a data scientist for a long time. If there is data in a database, doesn't matter how big, doesn't matter how fast. If it's in a row and column, I can do pretty cool stuff with it. We all have. We can predict, we can optimize, we can find out propensity of churn, all sorts of stuff. But if that data source is a contract, if that data source is a contact center call recording, if I'm going to send a home loan offer to a customer, but that morning the person called in and said that person has lost his job on the contact center and the call is recorded for quality and training purposes, how do we bring that together? That's where AI suddenly took off in the last few years. unstructured content became massive. That's been touched on a few times today. Technology, hardware, infrastructure became more accessible. The cloud happened. So suddenly, all of you have access to the best AI platform, IBM Watson, for free. You can go to the cloud.ibm.com website right now, sign up for free, build your chatbot for free, build a visual recognition engine for free. The way it works is, of course, there's the low entry point, and then after 10,000 API calls, you have to pay cents for each call, et cetera. If you're an enterprise, you have options of having that on premises. It grows, but now you have access to it. It is about bringing the humans and the machines closer together, both from the humans being able to interact with us and understand human-created content, primarily unstructured, and for humans to be able to interact with machines without having to write SQL code. It is about bringing machines to everybody. My 8-year-old son does not appreciate what's happening when he's going up to the Google Home and asking for the weather. Or will it rain tomorrow because he has to play cricket? That is what AI does, right? Now, why is this different? Human beings in our heads, and each of us have this thing called a cognitive framework. The cognitive framework is what all of us have. It's each of our own. We use it, we listen with it, we read with it, we learn with it, we make decisions with it, we make good decisions, bad decisions, whatever it is, we unlearn with it, and we do it in milliseconds continuously. Every one of you in this room who is not looking at their phone right now, apart from thank you taking the picture, that's fine, not looking at the phone, actually listening to me, you're going through a lot of stuff. You might be thinking about your calendar, you might be thinking about this in the context of the previous presentations, this in context of Skynet, this in context of movies you have seen. You're trying to understand who this dev guy is, why is he speaking so fast, what is that accent again? You're not even doing it consciously, it's happening. Machines didn't work this way. Machines were big if-then-else statements. So we needed a way to step away from this if-then-else approach and give it a way by which machines learn to learn. So we taught machines how to learn and start understanding context. This is where AI happened. So the best way to look at AI, and this is I do this a fair few times. In fact, I've used this slide in its current form for almost 4 years now. It's simple. If anybody asks you, what is an AI system, just remember this thing. Remember the acronym URLI. Yeah? You will remember URL? Yes. For those who are listening. Add an I to it. It's not that hard. But the main point is an artificially intelligent system is a system that understands an interaction in the context of its environment. Once it understands that, it can reason for itself to come up with what would maybe, or decide what's the next best step, not next best action, what is it looking at? Should I send it to a rules engine? It understands and reasons for itself, and it does it in a fairly autonomous way once you have trained it and taught it what to do. The third part of it, learning, is a really, really important point, to the point where many people will call this a synonym, AI and machine learning. AI systems do have machine learning techniques in them, and there are various kinds. Today in enterprise, most people use supervised machine learning techniques, where you sit down, you teach, you give it some input, you give it some output, you train it how to look at the difference between the two, and you have supervised techniques. Businesses need that because they need to be able to step back and say, if somebody's insurance claim was denied, you can't just say machine said so. You need to be able to step up and say, this is why you were not given your claim. So that's not a transparency, which kind of feeds into the ethics conversation, and we'll touch on that if we have time, is really, really important. So businesses generally use supervised learning techniques. Unsupervised, reinforced. Reinforced is a growing platform right now, which is kind of halfway between supervised and unsupervised. Unsupervised is what it is, what it sounds like, where you give it the data and let it figure out patterns in itself, and there are different kinds of statistical models that get used. Generally, though, there are three broad spectrums of AI today from a timeline perspective. I joined Watson in 2013. We launched Watson in 2011 to the world. If you have seen it, haven't seen it, on Jeopardy, which is an American quiz show. Just Google it, you'll find it. But it is narrow AI. That part was narrow AI, which is very specific. I'm just about starting to build image recognition models, just about starting to build natural language. I can understand some keywords. I can understand some language portions of it. Really, really bad machine translation started at this point of time, right? So this is that space. The future, which is general AI, which is a machine that can answer any question, understands general knowledge, it has everything in it and understands every context, that's a little further out in itself. But where we are, businesses on a day-to-day basis today is broad AI, which is a step up from that's an image showing a room to I know the people who are in the room. I know that person is where it's so many people in the room. I recognize 50% of them. These are the people who are in the room. It's going into that space. So it's a little more broad. The capability is a little more broad. This is where most of our customers are using AI today actively. So I touched on the different kinds of learning. Kaveh, I'm happy to share the slides and we can make this available. We can send this out to you. But look, the way generally at a high level, the way supervised learning techniques work is this approach where you import generally, or first you curate representative data, really, really important. Curate the right kind of representative data. Once you've got that together, you give it examples and you tag them. Really, that's what's happening. You tell the machine different things that define the data that it's going to get in the future. And you teach it how to make connections and relations and understand the data, right? And once you've done that, you've built what is the model. And then you deploy the model and you run it. And you let it do it itself and start getting text, images, sound that it has never seen before and tries to now categorize them and classify them based on what it's seen in the past or what you've trained them with. That's really what's happening at a super high level, right? Of course, there's depth through the whole process. But really in business, and that's where IBM focuses heavily on, where how enterprise uses AI, without a doubt, that is the primary focus that's being used heavily. There are obviously general retail consumer use cases, and that's okay, and you'll find a lot of startups using it. Last week, I had a whole bunch of high school students I was teaching how to build rock, paper, scissors using Watson and Scratch. Right, so yes, that'll happen, and that's exciting, and that's goodness. But generally, when this goes into business, like any other enterprise technology, there are certain facets of it that become really, really, really important, right down to the point of core business continuity discussions. When you have a technology model, you need to have things like ethics catered for, responsible usage of technology catered for, right kind of data catered for, recognition of bias in the data catered for. How does that fit into my current team's skill set catered for? How am I going to train my team right now to be able to use this? All these become important part of the AI discussion in enterprise. And the good thing is IBM's done this for a while. So we have fairly well drawn out frameworks, and I won't go into the depths of it, that work through what you should consider when you're starting your AI journey in a business. Are you going to start from one use case? Are you going to start from an enterprise view? Are you going to do both? So for Westpac, for example, I was part of the journey where they went in and used Watson, and they for the first time, they had an enterprise-wide AI platform implemented. For a bank, this is a really important discussion. Business loved it. Technology loved it. But the legal folks, bless them. I know I sound like I'm being sarcastic here. I'm not. They really took us through step by step. How does that impact customer type A, employee type B? Where does APRA fit into this conversation? It was painful, but a thing of beauty. We both came out better for it. But that's how it works in the enterprise world. This is not just about getting some free access to something and building something out. This is about taking ownership of doing it right. In AI, though, there's a broad spectrum now. There's a broad spectrum of topics and use cases and technology that comes under the banner of AI, right? So from robotics, which is really more the hardware side of it, so the AI part of it is in the code that drives the hardware side of it, machine learning systems, natural language systems, deep learning, all these different things that you have, and I don't have time to go through every one of them here today, comes under the banner of AI. So AI is almost like a big umbrella banner. So are they synonyms? No. Are they synonyms sometimes? Maybe. Yeah? And we have tons of customers. I've got actually a whole bunch of customer names. I won't go through one of them. I'll just pick on a few of them. So legalmation is interesting. So anybody doing law? Anybody studying any law right now? No? Okay. I can speak freely. So if you are a lawyer and if you've been a paralegal, life can be quite hard. You get these, cases coming in and customers' documents coming in, and all you have to do is it takes you like 5 days to read everything and come up with the first draft that a senior lawyer will take and start working on. Legalmation kind of automated the paralegal's life. Basically, you take all the documents, it automatically read all of it, understood what's happening here, it's been trained, and it doesn't do all kinds of law. There are certain kinds of law it did, because law has two interesting facets, which is one, it's unnatural language. It's not natural language. That's one. The second part of it is there is no one law. So that's why you have a commercial lawyer and then a family lawyer, and they live completely different lives. So they did it for certain kinds of law, and then it allows them to literally take all the documents, read all the precedents, and come up with the first cut in a few minutes, completely changing the paralegal's life. You had things like, these guys, this is a British company, where they have now an app, and they're an auto repair company. You basically call them, something's happened to your car, they will send somebody over, like think NRMA style, they'll come across, they'll fix it, broken windshields, all that kind of stuff. Now though, you take their app, you take a picture of your car accident, and they'll give you a quote on the spot, automatically. So Watson recognizes what's happened, that sends all the metrics required to their rules engine to come up with a dollar amount, and they hold to it, right? It's interesting stuff. Max Kelsen, Australian company, look it up. Really interesting use case up near Gold Coast. Woodside, probably the one customer in my career that I've learned the most from, and probably Westpac is the other one, because they keep pushing us to build some really interesting stuff. I'll skip this because I do want to spend a few minutes talking about the trust and transparency part. And this is really important. We have recognized that when machine learning happened on structured data, rows and columns, and then a customer or government or a regulatory body knocked on your door to say, why did you do X? It's a lot easier to find out because things are in rows and columns. You can almost simulate exactly what happened. But when things are not in rows and columns, when things are an image and a contract. So for example, imagine you have had a car accident and there was a really expensive tennis racket in the boot. Is that racket covered in your insurance claim? That's not there in any document. How do you make a machine recognize that the racket is covered? So is that only AI? No, there's AI components, there's a recognition of language components, there are some rules engines, there's some checklists. All that process happens, right? But you need to be able to have a process where I can type in a case number and relook at exactly what happened and then say, you know what, we've gone through 1,000 different variables for your claim rejection, and this is why this particular reason. So we were 93% sure of this particular reason. That's one aspect of it. You need to be able to cover it. And this lack of transparency and trust with AI is one of the reasons why large number of business haven't gone out and done mass production of AI. Skills is a big issue, of course, but trust and transparency in the models is the other big aspect. So only 1 in 20 companies have extensively incorporated AI, and this is, I think, last year's numbers. Right, so Again, IBM being the company we are, we have spent a lot of time figuring this part out. So we have built a product called AI OpenScale, which does a few different things. It actually goes in and looks for bias in the data first. So there's one aspect of it that you know why a model resulted in a particular output or a classification. But then, is the data that we have trained it on right? Is it biased towards a particular type of customer? So you can do bias detection. Once it does bias detection, if it identified bias, it will actually go and tell you that these are the things you should do to change in the data to remove the bias. And then you can rerun the data again by removing those bits of data and see if the bias changes. Beyond that, it gives you a nice little interface, and you have to do that by model, where every model is tracked. The payload that goes into the model and the payload that comes out of the model is tracked. And you can see exactly what variables got triggered through the payload and understand where different questions can be asked of the model, which of course allows you to do the traceability so you can link back. And this, we have done two things with this. One, we have created something called the AI Fairness Toolkit. So we have open sourced the underlying part of this so others can use this. So you can go and just find it on the internet. The other thing we have done is we have made these not limited to Watson only. So if you are using, TensorFlow, you're using, some other vendors, AI models, you can track the payloads with OpenScale, which is really powerful. And it's not going anywhere. So last year alone, I think we had something like 1,800 patents for AI alone. So there's a lot of focus happening in IBM. We are infusing AI pretty much everything we do going forward. I love the project debater. So one of the things I have kind of picked up over the last few years is this. A job of a good AI engine is to give you a good answer. The job of us humans is to ask the good questions. This is where we work together, right? Now, what if I could use AI to come to the good questions too? So I can debate with an AI engine. That's what Project Debater is. It actually debates with a human on a point of view. Have a look at it, just do a search on it, look at Watson Debater, fantastic video online. It actually shows you the live events where it did the session. So it's happening, we've sent Watson to space, that is Simon, which went to last year to space and was like a astronaut's help within the spacecraft. That was connected live to the IBM cloud in Germany. So when the questions will be asked of it, it actually worked back on. So I think that's my favorite IoT project ever. It doesn't get better than that. So in wrapping up, where can you go after this? So there's a lot of stuff that we have made public with Watson. There is training material. So the top left that you're seeing out there is a screenshot of the public cloud. So you can go to cloud.ibm.com, sign up, it's free. Look at the Watson engine. There's a lot of information available, training material available. Top right is the IBM Skills Gateway. Again, sign up for free. There are paid and free courses available. So you can get, if you're looking at building a visual recognition engine, if you're looking at building a chatbot, there are 2-hour sessions that are free, and then there'll be certifications which cost money. The bottom right-hand corner, if you're not a data scientist and you're looking at becoming a data scientist, we have something called cognitiveclass.ai. It's a website. If you just go to cognitiveclass.ai, there's complete training programs on it. Multiple hours, multiple training, journeys, certifications, so badges available for free that you get. And the little tip here, if you sign up for Cognitive Class, you get $1,200 of credit for the IBM Cloud. The reason we did that is because some of the training materials require you to have a paid data science platform, so you don't need to do that. You can always sign up for Cognitive Class and not use it for that. And use other stuff. Some more links available for developers, for techies, for people who want to learn more about Watson. I'll share this out. But I'll pause here, and I think I'm exactly on 30 minutes.